Okay. Sorry, today I have another meeting from 2:30.
Okay.
Sorry, so I will send this answer to you. So check later.
Okay, sure.
Okay. Mm. So briefly, I explain the outline of question. So question one is Maxwell's equation, and from E field calculate the H field. That original uh, relation of E field and H field is rotation E equal minus j omega mu 0 H. So by calculating rotation E, it becomes only EX component, JKEX. This I missed. This is I. J. So the this is J Y component. So the uh, H field also become Y field. So this value equal to this value. So Y component of H field from this equation become this one. So the intrinsic impedance, the ratio of EX to Y become like this. So from here, this equation, the ratio become root mu 0 divided by epsilon 0. And answer to C is Y is HY is only Y component. So that is third answer. So this is the answer to question one. Is there any question from student?
No, sensei.
Okay. Then question two. This is uh, circular polarization. So maybe this is the phase difference is 90 degree. So EX, EY calculation become like this. So the total electric field at the t equals 0 only EX component. And a little bit time progressed, it become like this. And after that, more. So from this one, the field is clockwise rotation. That is question two. Is that okay?
Okay, sensei.
Next is question three. Question three is RF radiation pattern is a series of E, J, exponential multiply. So by multiplying the unit value, then A theta is the total series. And original series and multiplied series are subtract become only survive this first term and the final term. So from this relation, the series solution can be calculated by this this equation. So this is A, 1 minus this one, and this one. So A equal the ratio of this one. So by calculating this absolute value, the lower part of absolute value is this is 1 minus cosine phi plus j sine phi. So absolute value is become like this. The upper side similar. The difference is here the array number is included. The lower side n is not included. So this calculation result become this one. So this 1 minus cosine phi is sine square half side, half the angle. So the finally this the absolute value is expressed by this function. So the calculation, the figure of this function become like this, and the maximum value become n with 0, and the null 0 point become 2 pi divided by n. This is the answer of question 3. And next, question 4. This is the radiated power density from the antenna. So that is power density is pointing vector. So pointing vector is E field and H field multiplied. So H field has a relation with E field by intrinsic impedance. So that is shown in question 1. So the H field is replaced by E field. So finally, the power density is expressed by only EA. EA square divided by Z0. And total power is power density on the antenna aperture. So WA, omega A is this one. So the total, the power distributed in the antenna aperture is equal to this one. In the antenna aperture, electric field is constant, so omega A is constant. So only this integral become multiplied by the area of aperture. This is power, antenna power. And the electric field in the far field is expressed by this calculation. The aperture field integral over the aperture area. So the electric field on the aperture is constant. So this part become EA multiplied by S divided by lambda R. So from the definition of gain, the definition of gain is maybe given in a question. So put in the radiation. This is radiation is a spherical area. Antenna power is diverge in the spherical. The distance is large R. 4 pi square, R square is surface area of the sphere divided by the surface of the antenna power. Then this is unit power density. And this part is this square. So by calculating this equation, we can obtain this 4 pi s divided by lambda square. This is the expression of the antenna gain. So you understand this answer?
Yes, Sensei. But I don't think I can answer that before.
You can trace. So this is I don't yet receive your answer. Dr. Camilia now keeping your answer. So later I will mark your answer based on this marking is shown here.
Okay, Sensei.
Okay, so I must finish. And as for the information of the final exam, maybe your final exam is on the morning of 9 June, Thursday, in the afternoon. Your final schedule is given. From my information, your test will be 9 June from 2 to 5.
I think it's 9 July, Sensei.
Yes, yes. In the afternoon.
Oh, okay.
So, Dr. Camilia make question for the transmission line theory. Me, this antenna part. So, from two questions. One is similar to question 1.
Okay.
Another is relating to question 4.
Okay.
And I wait a moment. A mistake. Relating to question 1. You can see?
Yes, Sensei.
You can see this one?
Yes, Sensei.
Now, this is electromagnetic rating is 1, and the antenna gain is 1. And this is the Maxwell equation. So today's example is rotation E equal minus JV. This is minus J omega mu H. So today's example is this one. Okay? So the H field is given, we can calculate from H field. This is J omega epsilon E. Uh, this time, final exam, 2 questions are requested. So one is using this from E field to H field. Another is from H field to E field. However, the calculation method is same. Only rotation H equals J omega epsilon E. If this is rotation E equals minus J minus J omega mu H. So this rotation calculation is same. So there is 2 types of question in the question 1 relating to the electromagnetic field. Okay?
Okay, Sensei.
And one more. In the question, many small questions are included. So you must understand how to obtain the velocity of the wave. In this slide, many calculation is requested in electromagnetic theory. So the calculation method of velocity is included. So you must study this slide once more. Okay?
Okay, Sensei.
And finally, another question is the derivation of antenna gain, similar to question 4 of test 2.
Okay.
What is suggestion for the final exam in my part? So, as for the transmission theory, I don't yet have the final exam question, so I am sure. If you have a chance, ask Dr. Familia. So what part is included?
Okay, Sensei.
That is my suggestion.
So, do you want any extra class before final exam?
What?
Should we have another class before final exam?
Another class? Wireless and mobile?
No, for radio wave and antenna. So, before final exam on 9th of July, do you want to have another class on next week or next 2 weeks?
Already today I explained the contents. If we request more, I must explain the detail of the questions.
Okay, Sensei.
So, so I think no more suggestion can be given so far.
Okay, thank you, Sensei.
So please study once more electromagnetic part. So array antenna and patch antenna is not included.
Okay.
And in the aperture antenna part, so the calculation is in my antenna part, question is only 2.
Okay.
Okay.
Okay, Sensei.
So you contact to Dr. Camilla after this, and if you can give some suggestion, you please.
Okay,
Yeah.
we'll ask Dr.
A
Camilla.
meeting.
Okay. Wait, I have to familiar.
Okay,
Okay, okay, sensei.
okay. Uh, okay, today I will finish just on time. I must attend another meeting.
Okay, sure. Okay, thank you, sensei.
Okay, then I will finish. Thank you. I expect good result for your finances.
Thank you, sensei.
Thank you, Sensei.
Okay, bye.
Bye. Bye.